Hello friends, once again welcome. Today we are going to learn the effect of ambident nucleophile on the rate of SN1 and SN2 reactions. First of all, we should understand what is meant by nucleophile. Any atom or species containing lone pair of electron or electron rich and denoted by negative charge is called as nucleophile. Now come to the point, ambident nucleophile. So what is meant by ambident nucleophile? The nucleophiles containing more than one atom through which it can attach is called as ambident nucleophile. Means the nucleophile which attacks through more than one atom is called as ambident nucleophile. We can take the example of cyanide. In case of cyanide, it can attach through carbon atom as well as through nitrogen atom. So, cyanide called as ambident nucleophile. We can take the example when alkyl bromide reacts with sodium cyanide via SN2 mechanism to form alkyl cyanide. In this reaction, cyanide acts as nucleophile through carbon atom. Means in case of cyanide, in this reaction, carbon atom acts as nucleophile. But when alkyl bromide reacts with silver cyanide, reaction takes place via SN1 mechanism to form alkyl isocyanide. In this reaction, nitrogen atom of cyanide acts as nucleophile, and therefore we can say that in case of cyanide, carbon atom as well as nitrogen atom both acts as nucleophiles, so it is called as ambident nucleophile. Now the third factor, that is nature of living group, also affects on the rate of SN1 and SN2 reaction. In both SN1 and SN2 reaction, the bond between carbon atom and living group breaks in a slow step called as rate determining step. So rate of SN1 and SN2 reaction depends upon the nature of living group. The good living group increases the rate of SN1 and SN2 reaction, while bad living group decreases the rate of SN1 and SN2 reactions. So what is the properties of good living group? What is meant by good living group? The living group which leaves its position immediately is called as good living group. Now the properties of good living group. Now the bond between carbon atom and living group must be weak, and it is possible only when the size of living group is larger. If the size of living group increases, the bond length decreases and bond becomes weak. Second thing, if the electronegativity of living group is less, if the electronegativity of living group becomes less, then bond becomes less polar and must be weak. The second property of good living group is living group should be stable. Means once the living group departs, it should not be recombined back with carbon atom of substrate. The electron withdrawing groups, that is groups having -I and -R effect, increases the stability of living group. As we know, NH2 negative, OH negative and OR negative are the bad living groups, but they can be converted into good living groups in presence of acid. We can take the example. OH is a bad living group, so following reaction cannot be takes place. When alcohol reacts with bromide, so we expect the product as a alkyl bromide, but it is not possible because in this reaction OH is a bad leaving group and it should not leave its position immediately. But when same reaction is carried out in presence of strong acid, then OH bad leaving group gets converted into S2O positive good leaving group, and so the rate of reaction increases. When alcohol reacts with acid, we get a good leaving group and therefore we get a final product alkyl bromide, and therefore this reaction is a possible.